Good day, sir. For today's video presentation, I discuss about the distribution-based clustering. First, I discuss what is clustering. When we say clustering, it's all about the task of dividing the population or data points into a number of groups. Such the data points in the same groups are more similar to other data points in the same group than those in other groups. In simple words, the aim is to segregate groups with similar traits and assign them into clusters. That's the meaning of what is clustering. In clustering, we have two types. First is hard clustering. In hard clustering, each data point either belongs to a cluster completely or not. For example, in the above example, each customer is put into one group out of the 10 groups. Second one is sub-clustering. In sub-clustering, instead of putting each data point into a separate cluster, a probability of likelihood so that data point to be in those cluster is assigned. For example, from the above scenario, each customer is assigned to probability to be in either of 10 customers of the retail store. Next, another term of distribution-based clustering. Until now, the clustering techniques as we know them are based on either proximity, similarity, distance, or composition density. There is a family of clustering algorithms that take a totally different metric into a consideration probability. Distribution-based clustering creates and groups data points based on their likelihood or belonging of the same probability distribution, Gaussian, binomial, etc. in the data. So, this is an example of distribution-based algorithm. A major drawback of density and boundary-based approaches is in specify the clusters a priori to some of the algorithms and mostly the definition of the shape of the clusters for most of the algorithms. This is at least one tanning of hyperparameter which need to be selected, and not only that is trivial but also to unwanted result. Distribution-based clustering has a vivid advantage over the proximity and center-based clustering methods in terms of flexibility, connectedness, and shape of the cluster form. The major problem, however, is that these clustering methods work well only with data where most of the data points most certainly belong to a predefined distribution. If not, the result will overfit. That's all. Thank you.